Good afternoon, natural resource students. The past few days you guys have been working on a biodiesel lab. The biodiesel lab was completed pretty much yesterday, and what we'd like you to do is use some of the information to figure out the amount of calories, which can then be converted to megajoules per kilogram. Calories and joules are both units of energy. Biodiesel produces, when burned, a certain amount of megajoules. And what we want to try to figure out is if we made enough biodiesel. To do this, yesterday you took string, put it into biodiesel that was measured out, and tried to light it on fire to see how well it burned and heated up water. That experiment gave you data, and today you have time to work on trying to figure out what that data meant. A few side points that I want to point out is, one, when figuring out how many calories per gram, you need to use the initial weight of the biodiesel. You did this yesterday when you weighed the crucible and the biodiesel you placed in it. So it was the second weight. The first weight were just the crucible we don't really need. But the second weight, where you had the biodiesel plus the crucible, is what you need for your initial weight. The second weight will be the ending weight where you had whatever biodiesel was left over. Bailey, Alyssa, you guys will do the same, where you will use the initial weight of the crucible plus the biodiesel and just the biodiesel. It'll work either way on how we did it yesterday, and we were talking to your group, but either way will work. So back to everybody. Sorry about the side note about just Alyssa and Bailey. Back to everybody. You will take your initial weight and your final weights, then there. Your temperatures and your weights will be put into an equation that is found on the Flynn Science hyperlink that was shown to you about the soda can. When plugging that in, make sure you follow steps 1 through 5. On step 5, it gives you your final answer, which is in calories per gram. My advice is to find in Google a converter that converts calories per gram to megajoules per kilogram. That will help you on your graph. Today is kind of a work day to try to figure things out. Tomorrow I will be back and I'll answer some questions, but today gives you time to figure out the math, and it also will give you time then to begin the conclusion. Maybe you don't trust that you can get it. You can also begin the graph. On the biodiesel lab directions, the bolded items are the items that you need to do. You've already done with one substitute there, the background, which should be very easy because I gave you the information that needs to go on it in the bioenergy number 3 notes, and we went over in class. You then have the procedure, which you don't have to copy down, but you do need to get to your data on the biodiesel burning. That data is put into a table. That table then is turned into a graph based on what each group's megajoules are. I like to rely on myself before I rely on others. So make sure that you get their initial weights of the crucible and the biodiesel, and then their final weights, and get their initial temperatures and their final temperatures. I would not trust any other groups but my own group's megajoule readings because of the amount of math and numbers that each individual has to do. Summing everything up, do the math and graph and table today, along with trying to start your conclusion. If you did not do the background yet, that would be another thing you can work on. A reminder that if everything else fails and you're having so much trouble with the math that you are frustrated, you can of course do the news article, which is due this Friday, and you can also work on any of the other SAE material. Good luck. There is plenty of stuff for you to do to stay active if you want to take advantage. If you don't want to take advantage, you do not have to. You can, of course, choose not to pass at all. Have a great and wonderful day.